Well, hello everyone, and welcome to another video about math and all the wonderful things you'd like to speak of. I hope you're excited for this lesson today on fractional equivalencies. It's going to be a rockin' good time. Fractional equivalencies. It's a fun word to say. Equivalencies. All right, what do you call a boomerang that doesn't come back? It's just called a stick. That's an oldie but goodie right there. I remember hearing that one back in the day. Good times were had by all. Okay, today, this is a lot of words. And I'm going to read them to you, and then I'm going to tell you basically what we're trying to say. Okay, so your goal today is for you to be able to represent and determine equivalencies amongst fractions, both proper and improper, and mixed numbers that have denominators that are 12 or less, or factors of 100 and percents, okay? And you're going to be able to do this incorporating the use of number lines and concrete and pictorial models. So basically what we're trying to say is we're going to be able to say and use fractions that look differently. The numbers on the top and bottom may be different than the numbers on the top and bottom of this fraction, but they equal the same thing. That's what equivalency is all about. We're also going to relate them to percents and start to understand how fractions and percents and even decimals all show the same data. They're just written different ways. Okay, so some of this may make sense to you as I'm talking right now, and some of it may not, and it's probably because of the vocab, because there's some crazy words in there. So let's hop into our vocab. I think we have 4 or 5 vocab words today, and I know that's exciting, but let's get rolling. Okay, the first one is the numerator. Okay, the numerator, when you're looking at a fraction, it's simply the top of the fraction. So a fraction has a number on top, it has a number on the bottom, and then it has a symbol in between, that bar. And that bar really just means divided by. And you could say 3 divided by 8, you could say 3/8, you could say 3 out of 8. So if you're thinking about this as a pizza, and a pizza's cut into 8 pieces, how many pieces are all together? There are 8. That's the number. How many of them did you put on your plate to eat, or did I put on my plate to eat? I put 3. And I was being ridiculous because I'm going to go back and get 3 more later. But anyway, at the first, I got 3 out of 8. See how I said that? That's a fraction. Or how much of the pizza do I have on my plate? 3/8. Okay? And if I wanted to figure out what that meant, I would say 3 divided by 8. Then I could turn it into a decimal if I wanted to. Okay? So the numerator is simply the number that is on top of a fraction, which means there's got to be a name for something on the bottom of a fraction. Yep, it's called the denominator. Same thing. And it shows how many equal parts the item is divided into. So for our pizza, it was broken into 8 parts. Okay, you may have a fraction of your classroom, and you can look around and say, there's 23 kids in here. That's how many people are in our whole group. Okay, so that would be the denominator. And how many of them love my dad jokes? 22 of them, right? So 22 out of 23 kids love my dad jokes. Good stuff. The denominator is the number on the bottom. What's the name of the thing on top? Numerator, denominator. Numerator up top, denominator downstairs. That's a way you could remember it. My mind is blown. Let's go to the next one. Okay, proper fraction. Okay, you're going to hear this phrase a lot going forward. A proper fraction is a fraction that is smaller than 1. So any fraction, when you look at the bottom, so if I take that pizza we just were talking about, and I say 8, and I say there are 8 slices on that pizza, and then I ate all of them. I can't eat any more of that, right? One pizza came to my house, it was cut into 8 slices, and I ate all of them. So I can never eat more than 1 whole pizza if only 1 whole pizza was delivered, right? So if I ate 8 out of 8, I ate 1 pizza, okay? And so that same day that pizza came, my son come downstairs because he's excited about this pizza. And he's like, oh, I'm so hungry, but I ate 8 of the slices out of 8. How much did my son get? He got 0. He got 0 out of 8. So how much pizza did he eat? He had 0 of the pizza. So what we just learned right there is all fractions, if they're proper fractions, which means that the number on the top is smaller than the number on the bottom, all fractions on a number line are going to be between 0 and 1. So 3/8, if the pizza was out of 8, that would be 8/8. It would be somewhere in here, 3/8. 2/3, if the pizza was cut into thirds, where would that be? Well, we had 0, we have 1/3, 2/3, and this is 3/3. So 2/3 would be about right here. 53/89, that's a weird way to cut a pizza or whatever, but maybe there's 89 children running down the street, and 53 of them are singing a Justin Bieber song. Okay, so 53 out of 89. So the group is one group. This fraction is between 0 and 1. Proper fractions, super important. Proper fractions are always between 0 and 1. Then we have improper fractions. If we have proper fractions, then I guess it makes sense that we would also have improper fractions. And they are, the definition of that is that the numerator is bigger than the denominator, okay? The numerator is bigger than the denominator. In this case, so if we take this pizza, let's say pizzas were delivered to the classroom, and you ask someone how much pizza did they eat, and they said, well, I had 11 slices, and the pizzas were cut into 8 slices. They ate more than a whole pizza, right? Because the pizza is only cut into 8. So an improper fraction is telling us a number that is bigger than 1 as long as it's a positive fraction. So this is a positive fraction, which means I ate 8/8 of a pizza, so that's 1, right? And then I also ate, what's left over? 9/8, 10/8, 11/8. I also ate 3/8. So I ate 1 whole pizza and 3/8 of the next pizza. So an improper fraction, the number on top is bigger than the number on the bottom, and it will be a number that is greater than or equal, it'll be a number that is greater than 1, either positive or negative, depending on the fraction. And a mixed number, I kind of just showed you that right there. And a mixed number is a improper fraction that is turned into a mixed number. And so a mixed number simply means you have a whole number. So look at this one down here. We have 2 whole pizzas. I know, it gets to the point where you get real hungry watching my videos, don't it? Because I'm always talking about pizza or M&Ms or something like that. So a person ate 2 whole pizzas. So that is a whole number. And then they also ate 1/3 of a pizza, and that is a fraction. So that's where the phrase mixed number comes into play, because the thing we're looking at has a whole number and it has a fraction. It's a mixture of 2 different styles of numbers, okay? So it has a whole number and it has a fraction. Okay, and then equivalent fractions. I want you to look at those pictures, because when you're looking at fractions, you can represent them a lot of different ways, and it absolutely tells the same story. So sometimes I go grocery shopping on my way home from school, and my wife may be traveling or my kids have games, and it's just going to be me. And so I just didn't really want to go home and do a ton of cooking for myself. So I just stop and I get myself a frozen pizza. And when I go to get a frozen pizza, I put it in the oven, I wait for it to get done, and then I pull it out, and I typically just cut it right down the middle. And I just eat. It's weird, I know. So it kind of looks like a big watermelon piece that I'm eating. But I just cut it in half, and then I'll eat 1/2 of that pizza. Okay? Because that's how I roll. All right, so I ate 1/2 of the pizza. So look at this picture. That's my story. Okay, but sometimes I do that and my son is home. Okay, and so I will cut it into 4 pieces. All right, so I'll cut it into 4 pieces so that, because he doesn't like to hold a whole thing. It's just a ridiculous thing to do. So how much of the pizza did I eat? Well, I ate 2 of the pieces. Okay, 2 of the pieces out of 4. Now what you're seeing here is that if you look at the yellow or the shaded in parts right there, you're seeing that I still ate the same amount of pizza. So 2/4 is the same thing as 1/2. Are you seeing that? Okay, and then sometimes I got a little fancy and I want to hold tiny little pieces of pizza. So sometimes I get a pizza when it gets delivered and it's cut into 8 pieces like this one. Do you see that? That pizza is cut into 8 slices. And I eat 4 of them. So I must be eating a lot more pizza, because over here I just ate 1 piece. Over here I just ate 2 pieces. And all of a sudden I'm eating 4 pieces. Which one of those am I eating more pizza? None. They're all the same, because I cut it into smaller pieces and had 4. I cut it into a little bit bigger pieces, but I had 2 of them. I only cut it into 2 pieces, but I had 1. They are all equivalent because they represent the same amount of pizza or whatever the scenario is we're dealing with. Good stuff, good stuff. All right, so let's look at these from a benchmark standpoint, okay? So benchmarks are kind of a good thing to deal with, and it's kind of a good thing to kind of get your mind around, because what does benchmark mean? That means the most common, or the ones that we use when we're trying to estimate, or they're kind of user-friendly. Like if I told you from our fraction point 37 out of 52, that's not friendly. That's a really tough fraction to deal with. But if I told you 1/2 or 2/4, you just learned that 1/2 is like a number, is a fraction that we use a lot. All right, so if you're sitting there eating an apple and someone comes by, I'm like, how much of that apple have you eaten already? And you look at it and you've sort of eaten 1 whole side of it. You might say to yourself, well, the other side is full. This side I've eaten pretty much all of it. I've eaten about half of it. That's a friendly term we deal with. You wouldn't say, oh, I've eaten about 16/34. What? Who knows what that means? That's not a friendly term. So benchmarks are friendly terms. So if you look right here, we have all these fractions on this side are friendly fractions that you've probably heard before. Okay, let's start right here in the middle, 2/4. Okay, we just talked about this in the last slide. 2/4 is the same thing as half, right? There was something that had 4 parts, and I took 2 of them. So that's 2 out of 4. So that's half the pizza. How do you show that as a percent? Well, half of a percent is, or half in the world of percent is 50%. So 100% would be the whole pizza. 0% would be none of the pizza. What's halfway between 0 and 100? That's right, 50. All right, and how would I turn 2/4 into a fraction? Because it kind of helps me figure out the whole decimal and percent thing. So if you haven't seen my percent video, that may not make sense. But anytime you have a fraction and you want to turn it into a percent, all you do is take that fraction and put it over 100. So we figured out, what do I do from 4 to get to 100? We multiplied by 25 because we're trying to find an equivalent fraction. And what do I do from the 2 to get to 50? We multiply by 25. So 50 out of 100 is the same thing as 2 out of 4. It is an equivalency. It is an equivalent fraction. But now that I have 50 hundredths, I can say, all right, how do I turn that into a percent? Anything over 100 is a percent. Boom, that's where 50% came from. And then anything that has a 10 base number on the bottom, 10, 100, 1,000, 10,000, I can turn it into a decimal real easy because the place value for decimals, if you remember, here's our decimal. This is tenths. I'm not going to write all these out. That's tenths. This is hundredths. Okay. This is thousandths, 10 thousandths. Trying to get that THS on the end. 100 thousandths, and so on and so on and so on. So now that I got this and I just said 50 hundredths, I can go to a place value chart and say, let's write that down, 50 hundredths. And the 0 is at the hundredths. All right, so that's my decimal. And this, the only reason it says 0.5 is because any decimal that you have that ends in a 0, you can get rid of the 0 because it doesn't represent anything. But 5/10 is the same thing as 50 hundredths. See how that works? And we can do that for every layer of this benchmark, right? Every layer of these benchmarks. We can go down and say, let's do a real easy one. It won't take much time. We have 0/4. Okay, let's make that out of 100. Well, 0/4 is the same thing as 0 hundredths because 0 is 0. And if I turn 0 hundredths into a decimal, it represents 0. And if I have 0 out of 4, I have 0%. That one's pretty simple, right? We go up to the top and say we got a fraction that's 4 out of 4. Anytime you see a fraction with the same number on top and the same number on the bottom, it means 1 and it means all. So you ate the whole thing. You collected the whole thing. It's something out of something, so it means it's all done. So 4 out of 4 represents all. 100%, whoa, what was that? 100% represents all. Okay, 100 out of 100 is the same thing as 4 out of 4 because whatever I multiply by here, I multiply by here. So it's going to be an equivalent fraction. And 100% is the same thing as 1, right? So I ate the whole thing. And you can go down and do that with every one of these. 25%, which means, so I have 1/4. That means I took that pizza and I cut it into fourths and I ate one piece of it. I ate 1 out of 4. Okay, let's make it out of 100 because then I can do my percents and decimals. How do I make it out of 100? What did I multiply 4 by to get to 100? I multiplied by 25. What do I multiply the top by to get to 25? I multiplied by 25. So I got my new fraction is 4 times 25 is 100. 1 times 25 is 25. There's my out of 100. What is 25 out of 100 of a percent? Anything out of 100, you just take the top number and keep it as a percent. And then 25 hundredths. Remember I said that? So here's our decimal. Tenths, hundredths, 25 hundredths. And that's how you turn it into a decimal. And you can go up and down this chart and do that with all of these. But the important thing is just remembering that you take your fraction, whatever it is, you make it out of 100. And then once you make it out of 100, it's easy to turn it into a decimal and percent. Now, so all of these are out of fourths except 2 of them. You got this one and this one. And the reason they're on there is because those are very common fractions and percents that we do as well. And they represent 1/3 and 2/3. Okay, 1/3, if we make it out of 100, you can see it doesn't go evenly. So 3 doesn't go into 100 evenly. So if we said, what is it though? It's 3 goes into 100, 33.3333 repeating decimal. So then we multiply the top by 33.333, and we'd get 1 times that equals this. And that's why our percent that we typically use when we're talking about a third is they had 33% of something. But what it really is 33.3 with a repeating line over it percent. Just like when you turn it into a decimal, it's 0.33333 and over. And if we go up to 2/3, that's double what 1/3 is, right? So instead of 0.33, it's 0.666 and 66%. It's just moving around these benchmarks so that you have an understanding of what they mean in their equivalencies. So let's do a couple on our own. Let's look at this and say, how do we make all that work, that mumbo jumbo you just talked about? Well, let's make an example out of it. So here we have a piece that's cut into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is out of 10, okay? And how much of it is colored in? 7, okay? All right, so now let's turn that into, so first of all, we can do the decimal right off the bat. It's 7/10. Anytime you have a tenth on the bottom, just go back to your place value chart and say, where is tenths? Well, this is the tenth spot, right? So 7/10. So I put the 7 above that place value. So that's my decimal, 0.7. 0 holes, 0.7. But I can't do the percent yet because I have it out of 10, and a percent has to be made out of 100. So I put 100 on the bottom. How many times does 10 go into 100? Well, 10 times 10 is 100. So that means I multiplied the bottom by 10. So I have to do what? What? I have to multiply the top by 10, which gives it 70. And now, anytime I have something out of 100, that just tells us our percent, which is 70%. Okay, let's go to this next one. We have 5 total stars, and 3 of them are shaded in, 3/5. Okay, can't do the decimal yet because it's not a tenth. It's not a number based out of 10. So we're going to have to do this whole 100 thing. Let's put it out of 100. How many times does 5 go into 100? What's 5 times 10? 50. Oh, that got us halfway there. So let's double that. What's 5 times 20? 20, 40, 60, 80, 100. So it's 20. So I multiplied the bottom by 20, which means I multiplied the top by 20 because it's got to be equivalent. We got to do the same. What's 3 times 20? Well, that's 60. And now we can do everything we need to do. What is anything out of 100? Is 60%. Okay. And then we can go back up to our place value chart. Let me erase that 7 real quick. Okay, let's erase that 7. I'll go back up here and say, all right, now we got 60 100ths. So this spot again was tenths. This spot is 100. So we got to put that, the end of our number has to be at that spot. So 60 hundredths. Okay, so it's 0.60. Remember what I just told you before? Anytime you get to the point where you have a 0 at the end of the decimal, get rid of it. So I get rid of that and just say 0.6. Last one. We have 3 balls and 2 of them are colored in. Let's make it out of 100. Remember we did this before and we said, you got to figure out how many times 3 goes into 100. Well, it's 33.33333. So I multiplied the bottom by 33.3333, which means I do that to the top. And what's 33 times 2? 66.6666666. How do we make that as a percent? We say 66.6%, right? Because anything out of 100 is a percent. I'm just going to keep saying that until you get sick of me. All right, and then I say 66 100ths. All right, so I go back up here to my chart and I say 66 100ths. All right, whoops, missed the eraser. 66 100ths, and where would that be? Well, that's the same as the last one. It's 66 100ths, so 66 because this is 100ths. All right, so 0.66, but it goes on forever, so I'll just go ahead and put that repeated line right there. You see how that works? Not too shabby. I'm sorry, this is kind of a long one, but we just got to keep rolling. Now we take this one and we say, let's figure out which of these answers represent that picture. Okay, so don't go diving too deep. Just think about what you know about fractions and drawings and illustrations right off the bat. What do you see? Okay, so what I see is I got something and something that are completely filled in. So those are holes. Those are complete pizzas those are fractions that are going to have the same number on top as the same number on the bottom. So I have, this one is 8 out of 8 and this one is 8 out of 8. And anything out of itself, so anything with the same number on top and bottom, is just representative of 1. So right off the bat, I know that I have 2 holes. But then I have this other one that is not a hole. But it's out of 8 still. Okay? And how many of it's colored in? 1. So right off the bat, I know that this one works. Okay? Now we're just trying to figure out if any of these others represent the same thing, or are they equivalencies? Okay? So when you have a fraction, you would just simply break down the fraction, make it equal to 100, and do the whole thing. But right now we have a hole. So my advice to you right now is just leave that hole alone and let's just play with the fraction. Okay? Let's just play with the fraction. I'll tell you what that means in a second. So we go back up here and we said 1/8. And we're going to make it equal to 100. Okay? So we want to figure out how many times an eighth goes into 100. How many times does 8 go into 100? Okay, so it's a tough one, but you'd have to go do some long division for this one. Okay, so I'm going to try to do it right here. I'll erase it when I'm done so we can still see what we're trying to do. How many times does 8 go into 100? Because that's the inverse of multiplication is division. So we're just trying to figure out what that magic number is. How many times does 8 go into 1? It doesn't. How many times does 8 go into 10? It does. It goes into it 1 time. But it doesn't go into it evenly, which means we have a little thing left over, which is 10 minus 8 is 2. So we still got to play with this other 0 and bring it down here. How many times does 8 go into 20? Well, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So it only goes into it twice because 24 is too big. And then what did we just say? 2 groups of 8? That's 16. So we got a little bit left over. All right, well, let's not change the value of 100. So let's just say it's 100.0 because that's still the same thing. Bring that 0 down here and say, how many times does 8 go into 40? Well, the answer to that is, bring your decimal up, it's 5, because 5 times 8 is 40. I didn't give myself any room, but if I put minus 40 down there, you get to be 0, and you'd realize you were done. So what we did is, what we just figured out is we said 8 times 12.5 equals 100, which means I got to do the same thing to the top, 1 times 12.5, and that equals 12.5. So now we know that this little guy right here, let me erase a couple of things for us so we can get a little room. I'm going to get rid of this. Okay, get rid of all this little stuff right here. Okay, so what we've already done, let me go ahead and circle what we know so far. We know that this works because it's 2 1/8. Now we know that 1/8, just the 1/8, okay, is equal to 12.5 out of 100. All right, let's go place value chart. Where would that go? 12.5 out of 100. Well, we got the decimal, and we got tenths, and we got hundredths. Okay, so we got 12.5 hundredths. So it would go 12, and then a 5 here. So it's 120. You're dividing by 125, so it's 12.5. So it's 12 hundredths with 5 thousandths left over. So when we put that into a decimal place, we realize that 2 is still going to be 2. So that's 2 wholes. So I can put it right in front of it. 2 wholes and 0.125 is the fraction. Okay, so where do we see 2.125? Boom, right there. Okay. Now, let's go back to this because we did the division and we figured out that 1/8 equals 12.5. Okay, so that would be 12.5%, right? But we also have these 2 wholes. What does 1 whole equal? 100%. What does 2 wholes equal? 200%. And what does this guy equal? 12.5%. So 100% plus 100% plus 12.5% equals what? Well, it equals 212.5%. That guy right there. Seems like we're done, right? We know it's not this 2.18 because we know it's 2.125. It can't be 2 answers there. We know it's not this because we know it's 212.5. What is this guy doing here? I got to figure that. That's an improper fraction. So we want to see if our if that's an answer that could work as well. So let's go back to this. Oh boy, am I going to have to erase a lot of stuff right here. Let's get rid of all this mumbo jumbo up here. Okay. All right, so now what we know is we have 3 answers so far. Let's go back and look at this as a fraction. So it's a mixed number, right? It is 2 wholes and 1/8. How many, if we didn't put it as wholes, how many is that? What does that represent as a fraction? Well, it represents 8 out of 8. Well, what does that represent? Oh, that represents another 8 out of 8. So now we have 2 8 out of 8s, which is the same thing as 2. Oh, we got this last one equals 1 out of 8. So what do we have here? We have all this is equal to what when you put it all together? Well, the denominator doesn't change because all the pieces are out of the same thing. So it's out of 8. And how many pieces do we have all together? 8 plus 8 is 16 plus 1 is 17. I've seen that somewhere before. Yes, I have. Right there. Boom. Killing it, guys. Good work. Oh, let me go back. I forgot. We got to circle that. So now we have 4 answers that made that work. Okay? All right. Last slide, I promise. Which numbers are equivalent to 7 out of 9? And remember when I was talking about this earlier, I said that also means divided by. So we could set this equal to 100, or we could just go ahead and turn it into a decimal. So let's do that. What is 7 divided by 9? How many times does 9 go into 7? It doesn't. All right, so that means we have to put a decimal here and put a 0 because 7.0 is the same thing as 7. We have not changed the value. And when we add a decimal there, we have to put another one up top here. So how many times does now 9 go into 70? Well, if you know your times tables, you know it goes into it 7 times. And 9 times 7 is 63, and we subtract it. 70 minus 63 equals 7. It's not perfect, so let's do another one. Let's bring another 0 down. That doesn't change the value of anything. We get 7. Oh, bring the 0 down. We got 70. How many times does 9 go into 70? We just did this. It's 63. So I put 7, 63. I subtract, and a 7. This is just going to keep repeating, which means it's 0.77777. Booyah. There it is. So if it's 0.777777, can it be 0.79? No, because it's 0.7777. Can it be 0.799? No, because it's 0.77. So it can't be either of those. Okay? And now how can we turn that into a percent? So we have 0.777. And if you remember from anything you've done in the past, if you want to turn a decimal into percent, you got to move this decimal because we're going to be multiplying it by 100 to move that decimal 2 places to get our percent. So we move it twice. Okay, so now we have 77.7 with a repeated sign, and that makes it a percent. Boom. So it would not be that one. We're going to dive into a lot more of what I just did right there as we turn decimals into percents down the road. But now you can see how this works. Okay, they're all equivalent. All those things that we've been circling equal the same thing. They're just represented in different ways. All right, I know that was a lot to take in. That's one of the longer videos I've ever done, but I think it's really important. So take your time, ask the questions, do all the things you need to do. Okay, and I know that's a lot, so I just want you to stay calm. And so I want you to listen to my buddy who has a real good theory on. Just handles it really well, and it's my friend the skeleton. And so why are skeletons so calm? Because they just don't let anything get under their skin. Skeletons don't have skin, bruh. So cringy. Later, dudes.